one thing, some of the OSS contributions. Onyx, thank you for the archive of the project work. It's merged in. So that basically solves the problem where you have projects that are dead in the UI screen, and you want to just hide them from the UI or from the CLI. So thank you, Onyx. I don't think Onyx is around. Besides that, so I actually put together slides. So there is a more structured demo and condition around the features that we are going to talk about today. So let me open that and share it.
Yeah, you've got an echo going on, Ketan.
Oh, really? Okay, 1 minute. Is it better now? Probably noisy, but better. Yeah. I don't know what's happening. So maybe. So I do have a few slides. Basically, I think after it's been, I think next month it'll be almost close to a year since we open sourced Flyte. We have at the company, we have especially worked at Lyft. Within Lyft, we have worked on reliability and getting things up to date, make sure things work at scale, and reduce cost for operating Flyte at scale. But one of the areas that we think that we have not really paid attention after opening was usability of the platform itself, like how you get started quickly and so on. So I wanted to touch base on how we are trying to tackle that problem and what's the current roadmap look like. Because I think I have heard this from a few users, like they would like some newer features in the usability part. And I just wanted to touch base like what we are doing and what's the grand plan that we feel, at least for the next few months. So we basically have a capability in the open source where you can create a cluster on your laptop or in EKS or in GKE. It's not as straightforward as just saying here's a button and you can create an EKS cluster that working at scale. Everybody knows that. It's a little hard, but we have tried to make it as simple as possible to create a sandbox cluster. And you can create that. You can use some examples, use containers locally to actually register those examples and get everything running. So that's what we open sourced to it, and we've tried to define it a little bit. Then we realized that there is a need for some users who do not want to use like Flytekit Python or Flytekit Java. They want to just run some other processes without actually needing to install either of those components. And so we launched this thing called as raw container tasks. You can run arbitrary containers, and Flyte will essentially mount volumes of data into the container and read data back out of the container. One of the goals of that is like that will become our data medium for most of data accesses that any of the Flytekit libraries do, specifically for cloud scenarios that we don't directly support in those libraries. For example, today we in Flytekit Java and Python we support GCP and AWS, but if you want to run this on Azure, then the raw container tasks actually support you in Azure. From then on, we realized that the users, the way the users actually, like with Flyte, we always want to match the user's workflow. And one of the things with the user's workflow is that they don't really start with an entire pipeline. They start with one task or one thing to do, like usually a Spark job or a training job or a Python script or so on. And we wanted to allow users to scale that job out to multiple machines, and Flyte does very well at that. And so we exposed a function which was always a plan. So I think that came probably 3 months ago, we launched the capability of doing single task executions. Single task executions allow you to run one task at a time, track it, and then eventually you can take each of the tasks and put it together into a pipeline and execute a pipeline itself. And today, Katrina will talk about fast registers. So actually, one of the biggest pain points with Flyte as it is in the open source today is you always have to start with a container. You have to build the container and then go from there, right? And we wanted to reduce the problems associated with building a container where some users may not have complete grasp on using Docker files and so on. So we want to take that away and reduce the time it takes to iterate between changes in the code to testing it in remote. And this is specifically taking your code from local machine to testing it in remote. And then the next two sections are the upcoming things that we're working on. One of them is a major rehaul in Flytekit itself that talks about that essentially hopefully makes it easy for users to ramp up with Flytekit. You should be able to write code in pure Python, and Flyte should just work, or even Flytekit Java is kind of similar now. Flytekit Java and Flytekit Python more similar than not. Along with that, we want to make it really easy to extend tasks and add custom data type support within the Flytekit ecosystem. And we will talk about a couple of use cases when we look at the slide deck further. And I think this is one of the biggest pieces of work that we feel will help our users a lot because this gives them full local iteration whenever possible. And so the user story would be that the user starts with an idea, writes code in Python, tests this locally, to whatever extent they can, and then hits a button, test it remote. Now that is one task. From one task, you can create multiple tasks, test it locally, and then test it remote. Using fast register, change the iteration time between local and remote to be less than in orders of millisecond instead of minutes. And then the eventual goal is, once we have all of this, we want to provide a set of tools or templates that you can deploy Flyte to any cloud environment easily. We already have, you've seen the work in Customize that we've already done that allows you to make it easier to deploy to various environments. But I think there's a debate going on in the community about whether to use Helm or whether to use Customize or whether to provide our own templating system. So we'll be talking about that like earlier next year and making sure that we can provide the best way to deploy Flyte into any of the hosted environments. All right, with that, sorry. And just I wanted to, I think I touched most of this, but I wanted to highlight a couple points of why we are doing some of these things, right? Fast register, that's what Katrina will talk about in a minute, is essentially to improve velocity, iteration velocity for the developers. While the Flytekit Python overall is to actually reduce the verbosity in writing Flyte workflows and tasks and make the code more Pythonic so that it's very easy for new users to ramp up and have minimum set of questions that they ask about, oh, how do I do this? Or it should flow more naturally. If you are if you have ever written any Python code, writing Flyte code should be almost equivalent to that. And then the other reason why we wanted to do it is Flytekit today is extensible, but we wanted to make it even simpler to extend. We think we can expose an API that makes this extremely simple. And we'll talk about it. And the last bit for the simplified development, I think one thing that we want to focus on is when you start a local Flyte cluster, we want that to be minimal in overhead. Today it starts a Docker or Kubernetes environment. And there are some great developments that have happened in Kubernetes itself to make it very low footprint to start a new Kubernetes cluster, like microkits and kind and so on. So we want to leverage one of those and have a out-of-box capability of running Flyte locally. Yeah, and then the one technical, as I said. I will hand this over to Katrina. I don't know if she changed the diagram. I had some diagram in here. I kept it like that. But Katrina.
Oh, that's fine. Work on the diagram in the future. So thanks for bearing with us with this really elaborate diagram. Thank you, Ketan, for drafting this together. So yeah, fast register. What is it and what is it good for? So at Lyft, one of the things we've observed is that a lot of the tasks that require building a container in order to update the task definition. This includes most tasks like Python, Spark, Hive, etc. But it does exclude some like the Presto tasks, raw container tasks. Those obviously don't need to build a container. However, this process ended up being really, really slow. So what happened was, your ordinary user would make some code changes, commit them, and create a new container definition. And because of the way Lyft has base containers that use inside of our Flyte containers, sometimes this process would take about like 20 to like 30 minutes just to build for a single change. This is a horrible iteration cycle for our users, and people were kind of like incredibly frustrated by this, obviously. So fast registration kind of steps in to fill in the gap here. When it turns out that you don't necessarily need to rebuild your container because let's say you're not adding new code dependencies, you're not adding new imports, etc. There's no reason you need to rebuild your container. Fast registration actually, as we can take a look here at this diagram, allows you to upload your code changes to S3. And in the process of registration, we'll use the base container image, but during execution, we'll go and fetch those live code changes and apply that code artifact inside of your container. So here we have our happy user who's built his Docker image and his base container that he to begin working with. And as he's iterating and working on his code changes, he can use this fast register process to kind of elide the entire container build. And so here we can see at execution time, we're pulling the base container, and then we also pull and fetch the code artifact. So maybe this will make a little more sense with a demo. So Ketan, do you mind if I share my screen? Thanks. Cool. So let's take a look at some code we have here. So here I have a really trivial workflow. Basically, it greets whoever you want it to greet, prints out hi. Not very sophisticated, but you can use your imagination for what fast register can accomplish. So let's say in this case, I want to change the greeting here, and I'm feeling a little funky, so I'm going to make it howdy instead. So ordinarily, if I wanted
Katrina,
to go,
you might want to jack your font up a little bit.
Oh yes, apologies, sorry. How is that? Is that more visible? Okay, I don't hear complaints, so I'll go for roll with it. Yeah, so sorry about that. So here oops, that is an ugly greeting. So here we have our single fast workflow. It has a single task, which greets whoever the workflow input it happens to be. And in this case, we've gone ahead and modified our dummy task in order to change the greeting to say howdy. So our next step is instead of going through the typical registration process of rebuilding this container and then registering this updated task definition, we can switch over to our next tab over here. So I've entered my original container that I built, which has the old definition of the task in it. So we can go ahead and Docker run that. And then once we're in here, we can go ahead and use PyFlyte to run the fast register command. This is actually going to change soon, so you don't need to be within a container, but for the purpose of this demo, we need to. So here we can take a look. This is the PyFlyte fast register command. Takes in the. Sorry, I just realized that. Apologies. Different tab. Okay. Hopefully, is this more visible again? Okay.
I guess if you clear screen, it might be easier.
Oh, even better. Yeah. Cool. All right. So simple and big now. So we have our PyFlyte register command. Takes in a config file like a normal project domain, and then the command in this case is going to be fast register. It'll pass in a source directory as well to specifying the code that you want to upload. In this case, I'm using the Flyte snacks container and we're just in root. So let's go ahead and fast register our new code changes. Take a look here and see what's happening using our config file. In this case, we're checking to see if that code distribution already exists on S3, which is our blob store in this case. We hash the entire directory, so every time you make a code change, we're able to notice that we need to upload a new code distribution. But if there are no changes, then we just skip that process altogether. So we've gone ahead and compressed that directory, uploaded it to S3 to a specific hash directory for this version of the code. We've registered our workflow, tasks, and launch plan. Awesome. So let's go ahead and take a look at launching that. So I'm going to go in here, launch our workflow, see this workflow version 866 AF. That corresponds with the latest version that we just uploaded. Let's go ahead and launch that. Cool. It's doing its thing. This should hopefully be pretty fast to run because it's not exactly the most sophisticated task. Running, awesome. Normally it's a little faster. There we go, 10 seconds. Cool. And we can take a look at our outputs here. And that is wrong. Awesome. Of course, this demo is not working. Was just working this morning, so that is great. Lovely. Can take a look at some of the previous versions that we had here. So this one, I had an extra high that I added in as a test literally just this morning. Not sure what happened now. Oh, actually, I know what happened. Did I not save my file? Yeah. Okay, sorry about that. Let's try that one more time. But benefits of fast register, this should be a fast process. So hopefully this demo won't take too much longer. Cool. So again, we have a new version of the hash code because I changed the code. So you see that the version has changed. And again, we upload that compressed version. So let's go on back here, launch our workflow with our latest version. Sweet, okay. Give another 10 or so seconds. Let the suspense build up. Queued. Running.
Actually, this seems like a more of a planned demo this way. But you
Yeah, it was very you caught me.
Also, Katrina, maybe we should prefix the version with like something like fast or that.
Oh, sure.
So
yeah, so one of the things I've been suggesting is you just have a remote directory where you upload your code that's specific to your distributions, so that way you can organize them. But yeah, that's also another option. Let's take a look here. Hey, howdy flight crew. Look at that. Didn't have to wait for a whole container build this time. So a totally intentional demo all the way through there. Yeah, awesome. Okay, cool. So I will stop sharing. Actually, we can take a look. Would it be useful to kind of go over what you need to do in order to enable fast registration? It should be pretty simple changes. So we haven't quite built the docs yet here, but they're available on GitHub. So there's a few prerequisites that you need. You obviously need to bump your Flytekit version in order to a version that supports fast registration. And there's a new parameter that you'll need to add to your Flytekit config, which is this fast registration directory that I was talking about. And this is the intermediate directory where we upload those code distributions that we end up pulling at execution time. So you can either have a specific directory for your distributions in order to organize them, or we can go ahead and make a configurable prefix as well too, so you don't have those random hashes for your compressed, your tar files. And that's all you have to do. You do need to make sure that the role that you're using can write to this directory and also can read from it as well too. But after that's done, how to. So merge your changes from above, make your code changes like we saw, and then go ahead and run the fast register command. And then once you once that's succeeded, like we saw, you can go ahead and create a new execution. And what this is doing under the hood is at execution time, we actually run a separate fast execute command, which goes ahead and pulls that code distribution, installs it, and then creates a new process to go ahead and run the regular PyFlyte execute command so that it can pick up with the latest code changes. So pretty straightforward, pretty simple, but a lot faster to iterate on, as you hopefully saw just now. So yeah, that's that. Hand it over to Ketan to talk about new Flytekit changes.
Yeah, that's awesome, actually. This eventually will also, the aim is that the users don't need to have Docker containers to iterate on examples and things like that locally. You can get started, just go ahead and modify the code and move on. All right. Thank you for the demo, Katrina. Again, I am mostly just talking because he did not want to talk, so I'm talking. But this is all Yi's work. So Flytekit, we've talked about it in the last time, but I just wanted to give a little more deeper dive into all the features because they are now fleshed out in code and they are available in alpha. And I'll quickly give you the instructions of how to access the alpha at the end of the slide deck. But before that, what is the change? So important, you just need one import, right, for task or a workflow. So that from Flytekit import task or workflow is always constant. That's the import that you need to do to create a task or a workflow in the new Flytekit. If there are plugins that you want to use, then they're always standardized. So they might be in different packages, like instead of from Flytekit.task plugins.spark, it could be from my thing dot x import a type, and the type is what qualifies the plugin. And we'll see an example of how that is used. And then you go about writing your task. And when you write the task, you just write a Python function. You write a Python function, you specify inputs in Python native types, and you specify outputs in Python native types. There's always one decorator. There are no sidecar tasks, and you don't have to come up with funky names. You just come up with one name, which is called add task. And if you drop that add task decorator, then it becomes a pure Python function. And that is by design. We wanted it so that you can start writing Python functions and then add tasks where applicable. From here, you go to defining a workflow. And in this example, if you see, this is the diabetes workflow that we had in one of our first examples. It's still the same, but it looks very different because you just have a function and you take a data set, which is a CSV. And if you notice over there, we have a flight file type. We'll talk about it in a minute. It's type CSV, and we take a bunch of other values. The interesting thing is defaults now are also very natural over here. You just specify defaults as if they were the default values for a specific thing, input type, and then they just work. And then if you look at the way the workflow is structured, it's essentially calling a bunch of tasks, and each task returns inputs and outputs, and those inputs and output gets passed around as you expect in a normal Python function, and that gets converted to a Flyte workflow. And there are a couple caveats, we'll talk about it. And the last part is you can execute all of this locally, and this is actually from that file. You can say like if name is equal to main, just run it, and it'll just run that thing locally. So you don't need to even go to fast register or build a container or do any of that if your code can run locally. But not everything can be run locally. You have a SQL task. How can you run that thing locally? You probably need to call BigQuery or Hive or whatever, Presto. So in that case, you can mock. So the bottom of this example over here shows that you can mock things. I know I'm mocking it to return a value string. This will change to return a type of schema, but in this case, I'm returning a value string, and you can execute it. And instead of actually calling the function itself, it will call your function or your mock always return your mocked value. So you can also have a side effect. And this is a full magic mock object. So you can do everything that you do with magic mock with this. All right. Dynamic tasks was one of the most probably very powerful but ill-designed primitive in the system, and we have gone in and rethought about it, because it's essentially is a dynamic workflow instead of dynamic task. Right? We are writing arbitrary workflows at runtime. We're generating arbitrary workflows at runtime and then executing them. So that's what it looks like now. A workflow and a dynamic is the new decorator that you use, but it's the same as that workflow. You can write everything that you can write in that workflow. The only difference is the inputs are materialized at this point. That means you can do interesting things like for I in range A, and then do things that you want. That's because the value of A is known, because this runs at runtime. Whereas in a workflow, if you do for I in range A on this value over here, that will not work, because workflow is a pure declaration and there is no value, right? It will run at runtime, and for loops are not understood by Flyte. So when you do that, but the interesting part is when you do that locally itself, it will fail. It will say like, oh, you can't use for loops inside some workflow. I might not say that, but it'll say like it's impossible to get a range value from a promise. All right, the next bit that is a powerful feature in Flyte, but sometimes could be hard to use, is a schema. And I think, I don't know if some other new members of the community are here who are interested in helping us with redesigning the schema. But here's the existing schema, and we are just bringing it to the new world. A schema is essentially a columnar data structure. You can model it using columns. And here's an example. Also, we have replaced blob and multipart blob in the name. Like we didn't like the name for the users, because for users of Python, that really doesn't make sense. It's a file or a directory, and that's what it is. So you call it a file or a directory from the user point of view. One of the things to note over here is this is a generic Python type, and you can create a format inside there. We are still debating as to how to really represent the format, but this is the current incarnation. And you can say, FlyteFile takes a CSV, or this is a CSV file. And we'll upload a CSV file. The benefit of using formats is if you have two tasks, one that produces a CSV, one that consumes a CSV, we will assert and we will do a static type checking on the type of the file also. If you specify it, if you don't, then it's an optional thing. Similarly, Flyte schema is now a generic instead of the schema object you have, and you have all the column names over here. The column names is essentially an ordered dictionary of key value pairs, where the keys are the names of the columns and values of the types of the column. And you just define them. One of the cool things that happens is pandas data frame is now natively understood by Flyte. So if you return a pandas data frame, but you have qualified the function to return a Flyte schema, then we will auto up convert from pandas data frame to a Flyte schema. And we'll quickly talk about how the type extensions work. So you can add these type extensions, this auto converting for Spark frames, other types of data frames, anything that conforms to what a schema is. All right. So extending task. We know current Flytekit allows you to extend things easily, but we wanted to make it even simpler. And so in this case, as an example, I wanted to just add a new Python function task type called my Python function task. And now it can be of two types. We always said that you can have a Flytekit only task extension. And that's useful in providing different types of interfaces, for the users. For example, I may want to wrap up a function and make it so that it runs on one element at a time. And I want to provide that as a common functionality. to all my users. You can write that as a pure Python function task. For Flyte, it's still executing one container, but internally you are executing multiple functions. And so that can be done using just extend this, just implement the method execute, and you're good. If you have a backend plugin, you can optionally implement the method called get custom information, which returns a dictionary or a JSON. And this JSON gets converted and transported to the actual backend plugin, which should know how to decipher it and use it for the runtime execution of the plugin. The other part is these plugins are all lazily embedded or lazily registered. Sorry, I should have updated Spark. But you can basically register Python task plugin with the type. In this case, the type is the type of the generic object here, so my object type, and the name of the class, and that's it. Once you do that, this function type or task type is now registered with the system. So this allows you to now register new task types and user line. Like you can just create new task type, register it only for yourself, and use them. The other thing is the types. Types are also just like tasks, type system itself can be extended. So for example, if you're using primitive type like integer, date, time, they are all handled already. But let's say I want to write my own exotic type. Let's say that type is, I'm in bioinformatics and I have a specific type for, showing or modeling DNAs. I don't know, maybe I'm saying something completely wrong, but I have a specific type. It's essentially a binary format, and I want all my users to use that type. Then you can create a type for modeling a DNA and register it with Flytekit's type engine. In the backend, you can provide an implementation, and that's the transformer. And that transformer actually just converts from the user type to Flyte understood type. In this case, let's say if it's just a binary file of some sort, you could convert it to a file. And in the file, you will probably add the format information to be DNA file or something. And you have to do that, you have to implement 3 methods. What is the type of that thing? And when I say type here, it's actually converting to the Flyte type. And when I give you a value, how do I convert it to the Flyte type? So you implement that method. And when I have a Flyte type value, how do I convert it to your value? If you just implement these 3 methods, you can extend Flytekit's type engine to encompass any type that you want. And this is especially useful for domain-specific types. All right, so
we got about 4 minutes before they're going to kick us out of the meeting, and we can restart it. But if you want to,
yeah, no, I think I'm almost done.
Okay.
So the current state, pip install alpha 1 is available now. To get started, you can just say pip install Flytekit 0.16.0 alpha 0. It is in a separate branch in Flytekit. It will eventually get merged into master. And all the examples, we have tried to put it together in a separate branch in FlySnacks. Again, there are not many examples and a lot of documentation that's coming soon, but hopefully this quick primer will give you a way to get started. And I wanted to give you a quick update of what's coming up next. So branching support, and I'll show you an example of how basically we have native branching within workflows. Multi-image support. So Flyte backend does not care about what image you use for a task, right? Each task can be a separate image, but there's no very easy, clean way of really doing this for the user. And so we think we have one way, and that'll be part of Alpha 2. Lots of unit tests, and we are going to port over most of the task types. We are hoping that the Alpha 3 will try to allow you to use tasks from the older SDK or the older style and mix them with the newer style. And that would be the backwards compatibility model that we'll go ahead with. You won't be able to use new tasks in the old workflow. You'll be able to use old tasks into new workflow. And then we are hoping that the GA should be end of the year. A quick look into how the multi-image support is going to work. So if you have a task, You can have a container image in which you can specify, instead of always having the default image, you can say that I actually want an image whose FQN remains the same as a different version. In this case, for Spark, I'm building a different image. I'm building two images, one called Spark hyphen the version name, and another one just with the version name. So in this case, both the examples will have different images, or both the tasks will have different images, and they are used in the same workflow. Now, to use it in the same workflow, you have to have all the images installed.
We are out of time. I'm gonna have to end the meeting, and then I'll restart the meeting, and everybody can rejoin if they want to pick it up. But Zoom is going to do that for us in about 30 seconds.
Yeah. So I would like to answer any questions if people want. So please join back in. What would be the URI?
It's exactly the same URL. I just have to end the meeting, but you can click back on the same URL in about a minute, and it'll all come back in. So,
okay.
All right. We're going to end this right now, everybody, and then click back on the same link that you joined this with in about a minute, and we should be ready to go again. You're muted, Ketan. Yeah, I think when you come back in, it mutes you by default.
Yeah. Sorry about that. I'll repeat. What I was saying was, I'll quickly talk about multi-image support again, and specifically from the use case point of view. The use case over here is if you want to use GPUs for some specific task, and it could be machine learning, or it could be image processing, or any other case, or rendering, right? But in another task, you don't want to use GPUs. You want to do some machine learning using scikit-learn on CPUs, right? Doesn't matter. And in another task, you want to do Spark, which doesn't care about GPUs in this case, and you just want to do some data processing. What you'll do typically today, because of the way Flytekit was built, is that you'll have to build one image that has GPUs and Spark and scikit-learn, and that's nuts. Like, it's crazy to build that image, because that image size becomes many gigabytes. With this change, what we are hoping is that users will build multiple images, one specific for that use case. We still think that the versioning should happen in sync, so that you can make sense of what's happening. Like, oh, I built 4 images and all dependencies that are directly involved in that module in the documentation. So that's the multi-image support. For conditionals, this is the syntax we are going ahead with. We would love feedback. If somebody absolutely hates it, we would love to know, and please come up with ideas also. The syntax over here is, there is an assignment that's happening. So by default, and this is Flyte's way, is like every conditional it's more like a ternary operator in languages. So it returns a value, right? So the output of every execution within the conditional returns the same set of, or a same type of value. And that's the interface of a conditional. And that is automatically derived from the tasks that you invoke within your condition. And then you can do if, then, else. And of course, you can do else of a function like T2, like task, or you can fail. And failure is okay because it's not returning an error. It's actually raising an exception from Flyte's point of view. So that's fine. So that's how the conditionals are going to be. They'll also get merged soon, and all of this is slated for alpha 2. And that's it from my side. I don't really need to do a demo. I think all of this runs locally. All of the examples in native typing Flyte stacks run locally and on remote. And I think I can show things running locally if people are interested, because I think there were users who were interested. So in this case, we do have sub-workflow support, we have dynamic support, and so on. So this is a task, it's returning A. You can't really name output returns. So if you want to name them, you can use a name tuple, and then the variables in the tuple become the names of the output. But otherwise, the output name is auto created. We will create a default name like O0 or out0. But you don't even need to know, because you're in your workflow, you're just working with the outputs themselves. And then you can just run this locally. They should just run it locally if my environment is set up correctly. Yeah. Similarly, as I said, you can have SQL tasks, but you can mock it. And you can, once you do that, you can run the mock locally and assert that it returns a hello. Same thing for conditionals. And Spark, even the Spark stuff, if you use PySpark, it runs locally completely. So you will be able to write regular Python code and write Spark code, and all of that runs locally. It uses PySpark local mode, and it will set it up correctly so that it runs. And yeah, of course, like things like where you're applying constants to a value are supported, so you can bind constant values to a function, function invocation. So because this is not declared as an input, it's declared as a constant, we will automatically convert that to a constant, the declaration of the workflow. What else? Expressions can be complex, right? These if-else expressions can be complex. One of the weird things that you have to do is, instead of saying and in Python, because and is not exposed as an overloadable object, we have to use binary and, or is it called unary bitwise operator and. The problem with bitwise operator and is the precedence is higher than comparisons. So if you don't put brackets, it will try to do an and of these two things. Thankfully, the compiler will fail, saying that, oh, you can't and do objects because there's no binary, bitwise and between them. But that's like a quirk of Python. Besides that, the Flyte file type. The idea over here is that we want users to start thinking about files as local objects and persistent objects. So once you start thinking about them being as persistent, you just work with files, and Flyte will take care of the rest of uploading it, downloading it. Now with Spark, you don't want to work with files in the file system, so that's okay. You can work with RDDs, but they are persistent RDDs automatically because we make all persistent. Them depends on the implementation. And yes, you will support OS or path-like, more of the natural Pythonic syntax. I'm trying to find if there is something special or that missed out. Yeah, you can invoke launch plans, you can invoke workflows, all of that existed with old, exists with the new, just more natural according to what we think should be. Also, we are moving to a more functional paradigm where you don't say a workflow should create a launch plan. You say, hey, create me a launch plan from this workflow with this type information. If you've noticed, we have if you have used the new Flytekit Alpha, there is no, at least we recommend not to use the register directly because register is not supported, as we think we are going to split the registration step into 2 steps. One is serialize followed by register, and serialize is where you need some context information with code and so on. Register can be done anywhere, completely independently, and the reason for that is we want to share the examples as a downloadable entities that you can register from wherever. That's the goal that we are going to get to. And I think our current setup for that, having one combined register, doesn't really work very well for open source. And we think this is better. Yep, that's it. Anything questions? Any questions? Let's talk about
it. Hey, Ketan. I had a question around, you mentioned like running the Spark test locally. It'll just use a PySpark local mode. Does the user still have to kind of set up PySpark, I guess, locally and install Spark and everything locally?
You have to pip install
Okay.
PySpark. I don't know if you also need to have JVM. Probably you need to have Java running locally. Yeah. I have to check because maybe I have it running already or I have it installed. So
yeah.
Okay. I think you need. Yeah, Soren seems to be smiling. He probably knows the answer to that. So, yeah, no, okay. Any other questions? No questions.
What? I have one question.
Yes.
So this feature of choosing a different Docker container for each, or Docker image for each task, and the stuff Katrina presented earlier, where you can actually change code and it will just be uploaded to S3. So you can freely mix that, right? So you could have a bunch of base Docker images, and as long as you don't have to like install a very specific dependency of some Python library, you could change the Docker image and also change the code and then run it on a different Docker image without having to rebuild.
You are astute, and that is right. You can do it. Now, is that a recommended way? Is questionable. So I don't want to advertise it, but yes, that is.
Sure.
So, for example, we might have a set of examples which just essentially is like, write whatever you feel like within this realm of things. And here are a bunch of base containers that you can use.
Okay. Okay.
And that's it.
Yeah.
You can absolutely, you're right that you can just no need to build a container ever in that scenario. Now, whether that's a good or a bad.
Yeah. If you really want it, it's another question. Just
yeah, like I think it's more like reducing our opinion over here, right? Like I think as a platform, you should probably not have an opinion on this. We still recommend using containers when you're productionizing things because they're just more like it's a natural package. But yeah, you are free to do it.
Okay, thanks.
Yeah, so actually one thing that I messaged Katrina about with that is, since like we use Bazel, well, quite a bit of users use Bazel, so it already includes all the dependencies as part of the code. So we actually don't have to rebuild an image at all. We could just use the fast register.
You can, yeah, that would be awesome.
Yeah, so that yeah, I'm gonna incorporate that in like the Bazel rules that I wrote and see how users like that.
Yeah, you might speed up, you make it even faster, I think. Because Bazel's anyways faster, I think this might be even faster though. Like probably a second or so to get it running. But what happens is when you reduce the friction so much from going from local to remote, people just start using remote all the time. And then your cost spikes up. So you have to be kind of careful. But yeah, what users want, users always right. So they want it, right? So. Yeah,
question, Ketan. So
yeah.
we're using some like local Docker build optimizations where we are, kind of like installing requirements like an earlier stage of the earlier step, I guess, earlier layer of the Docker build. How much faster will this be compared to that, do you think? Or is it just like something that we have to test? So for instance, for us, when a user makes a change, it'll just like, it'll cache, you use all the cache for everything and then just like do like maybe a 2 meg or something layer push.
Yeah, it's like, that's how it should be.
Mm-hmm.
That is the right way of doing it, according to me. Mm-hmm. Not everybody does it that way, right?
I see, okay.
It's like, you look at some of the Docker files and 99% people don't know how to optimize Docker files. It's sad, right? And then there are some weird things that people do where the code will be copied first and then the requirements will be run, and it's just right. It becomes slower and slower. So if you're doing everything right according to Docker, probably this is still going to be faster. But then why change that Docker behavior? It's just so much gap. Yeah.
Still, I'd like to test it because we have a sort of a situation where all of our development actually already happens in Docker containers. And so, like Flytekit and stuff is already installed in this Docker container, and like, and then users can just kind of like push. So what we're currently doing is like users just like build and push the image using Google Cloud Build, which leverages the cache from like, GCR or whatever. But then like they register from like their local environment. Oh, okay. So they're not actually like, they're not exactly like execing into the container or like, running in the container to like run the register command. So, but I'd be curious to see like how fast register works with this sort of a setup. I
think with that setup, right, you don't even need to do a Google Cloud Build again and again. You do it once when you modify your requirements, you just start using fast register.
Yeah, that's what I'm thinking. Yeah. Okay.
I will let you decide when is the right time to switch from fast. That's why we created 2 set of commands. One called fast register and one called register. And the reason is we still think when you're productionizing, you should use register.
Got it.
Yeah.
Good to know. Okay.
Yeah. Maybe at some point, probably we should have a feature in admin that says lock like staging and production environments or give the capability to lock any environments that you want. Should not get fast register builds. Mm-hmm. But again, opinions, it won't be opinions, it will be an opt-in feature if that is the case.
I see.
And we should all discuss it.
Okay, thank you.
Anything else? I think Sam might. Hey, Sam, thank you for joining. Do you have any questions? You've probably looked at the API. Sam's sleeping. All right, so if there are no more questions, the only request I have is please try out Flytekit Alpha. There are bugs. I'm not even going to say there may be bugs. There are bugs. Probably I just don't know of them. Let us know. It's really early alpha, and we will keep on improving it. Okay.
Cool. Thanks everybody for joining. We kept it under an hour, which is good. I'll post the recordings as soon as Zoom finishes grinding through it. So I don't exactly know what's going to happen because on the split meeting, because I don't know if we'll get 1 recording or 2, but I'll post whatever I have. And see everybody in a couple of weeks. And we are always, anybody who wants to demo their fun environment setups or how you guys have solved some of these problems. It sounds like people have been working on workarounds of the registration problem on their own, which makes sense. Anybody wants to show off their config, particularly the GCP folks who've been using some of the GCP tools that the Flyte team is not that familiar with, that would be useful to see. And anybody just DM Ketan and let him know if you want to, you want to show one of these off.
I had a request from Jeev actually. Jeev, we just talked briefly about the reaction events from GCS that you guys monitor. Would you like to share about that next meeting or something? It will be great for, I think, I'm sure most of us.
Yeah, so it's very young. We basically wrote it in half a day or something. We're still kind of iterating on it, but I'm happy to show how we're sort of thinking about parsing these things and using it in Flyte workflows. Yep. But it won't be it'll just be maybe 10 minutes or something, if that's okay.
Oh, that's more than enough. So we have thought a lot about reactive pipelines in different ways, and we would love to collaborate or coordinate any of our work in any way that you guys are open to.
Okay.
I think it could be generally useful to do something like that. I have my reservations about doing that on Kubernetes, but that's the only reservation I have.
Yeah, we're just we're just kind of starting to think about this now, and so these are just very early prototypes, but definitely happy to share what we've learned.
Yeah, sure. I think I'm also going to ask Spotify to talk about sticks and Flyte integration and how they are working through that, and I think there is also a backstage and Flyte integration in progress. So,
cool.
All right.
All right, everybody. See everybody in a couple of weeks.
See ya.
Bye.
Bye, everybody.